Alrighty, I keep going over 5 minutes, and I really hope this is the last time I record, but hopefully I won't go over 11 o'clock. Let's see how this goes again. So the first concept is logarithmic equations, and this particular equation will incorporate both the power and quotient rule. So the equation is 2 times log of x minus log of 7x minus 1 equals 0. Now when we look at this, we have to make sure that x and whatever ends up in the parentheses is greater than 0. So because of these two equations, we know that x must be greater than 1 over 7, or about 0.1428. So because of the power rule, we know that we can put the 2 as an exponent to the x. So we get log of x squared minus log of 7x minus 1 equals 0. Now, we can put this into fraction form because of the quotient rule, which says that this subtraction means that this would be the numerator to this denominator. So then we get log of x squared over 7x minus 1 equals 0. Now, because there is no base to the log, we can assume that it is 10. So if we convert this into exponential, we get 10 of 0, or 10 to the 0th power, equals x squared over 7x minus 1. And we know that anything to the 0th power equals 1, so 1 equals x squared over 7x minus 1. Moving down, we can multiply 7x minus 1 times 1 to equal x squared, and then we can subtract 7 from this side and also add 1 to both sides, and we get x squared minus 7x plus 1 equals 0. And we can make this into our handy-dandy quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we get two equations. We get 7 plus or minus the square root of 45 over 2, which is 7 plus and 7 minus. So for 7 plus, we can add 7 to the square root of 45, which is about 6.71. Divide that into 2, and we get about 6.855. Now, if we do the same thing to 7 minus, we get about 0.145, which if we check our handy-dandy golden rule, we know that this is, in fact, greater than 0.1428. So neither are extraneous and both are correct. Now, moving on to the product rule. Oops. Sorry, had to get organized there. Moving on to the product rule, we have log base 4 of x plus log base 4 of x minus 8 equals 1. Now, because of the product rule, we know that this plus sign means that we can multiply these two, the x and the x minus 8 together. So using our area model, we have x squared minus 8x. So log base 4 of x squared minus 8x equals 1. Then we can convert into exponential, which would mean 9 to the 1th power equals x squared minus 8x. So then we can subtract the 9 from both sides, and we get this quadratic equation, x squared minus 8x minus 9 equals 0. Because of the way that this equation is, we can use factoring, which is my favorite way, and we have x minus 9 times x plus 1 equals 0. Or, flipping the signs, because a equals 1, x equals 9, and x equals negative 1. However, if we look at that golden rule we made at the beginning, we know that x must be greater than 8, and because negative 1 is not greater than 8, it is an extraneous value, and only x equals 9 is a real answer. Moving on to concept 2, we have 2-point exponentials. So using this exponential equation, y equals ab to the x power, we try to convert, or we try to find the equation in which a line runs through this coordinate and this coordinate. So 2, 3, and negative 3, 239. So, and the asymptote is y equals -4. So we want to put each of these in the this format of equation. So we put y, -3, equals ab to the second power minus 4, and doing the same to both sides. For the first one, we're going to solve for a, and we're going to get a equals 1 over b to the second power. For this side, we're going to solve for b, and so we're going to input a after adding 4 to both sides, just as we did over here. We're going to get 243 equals 1 over b squared times b to the -3rd power. So multiplying 1 over b squared times b to the -3rd power, we get 243 equals 1 over b to the 5th power. Then, because I know that 243 is 3 to the 5th power, and I know that it also has to be the opposite because it's underneath, the opposite of 3 in exponentials is 3 to the -1, which is 1 over 3. So I can't quite explain how I know this. It felt like it was right because of the way that 3 is to the 5th power, but it's also on the bottom. So now we know that b is 1 over 3. So then we bring it back over here and we input b into this equation. So a equals 1 over 3 squared. Then we have a equals 1 over 9, which also equals 9. So y equals 9 to the 9 times 1 over 3 to the x power. Moving on to our final concept, part 3 of Aaliyah going way over this video, is the concept 3, triangles. So finding the area and sides and angles of triangles that are not right. So starting with the law of sines, we start with this triangle. As you can see, this is angle C is 73. And because of the law of sine, we can put it into this equation. Sine of b over 11, because that's side b, equals sine of 73 with the side that also correlates to that. So if we cross multiply, we can get 11 sine 73 over 12 equals sine b. Then we just get 8766 equals sine b. If we make this the opposite, the invert, we get sine, or I kind of forget what that's called, but the inverse of sine of 0.8766 equals angle B. We get angle B is equal to 61.2364 degrees. Moving on to the law of cosines, we start with this triangle. I apologize, this gets a little cramped. We start with this triangle, and we are trying to solve for A, the side A, so BC. And because of that, we want to use the angle A because that's what we're given. So we use the equation a squared equals b squared plus c squared minus 2bc cosine A. So we just input this into our equation. So a squared equals 9 squared plus 7 squared minus 2 times 9 times 7 times cosine 60. Moving it down, we get a squared equals 130 minus 63 if we break this up. Then we get a squared equals 67, so we take the square root of both sides. We know it can't be negative, so we won't do plus or minus. And A, the side of BC, equals 8.1854. And area of a non-right triangle, sideways, we start by using this equation. Area equals 1 over 2 ABC sine C, or AB sine C. And we have this equation, and so we input our numbers again. We're trying to find the area of this triangle. And we input 8 and 7 and 30 because this is an SAS triangle. And we multiply them together, and we get area equals 19 units squared.